after that last video, you might be wondering why we ever bothered to teach you to write the exponential graph and then make the points inverse when we could have just went log x over log whatever the base is to find the graph. But what you're going to find in these examples moving forward is that it's actually nicer to use that inverse of the exponential one because it's easier to control the values. Now, you'll see as we go through this one what I mean. For example 3, they want us to transform a logarithmic graph, and what they've given us is log base 3 of x to start with, and then they're going to complicate it. So we have one of these formulas that we've used before where we can pick out the individual transformations, translations, compressions and stretches, that sort of thing. Not a big deal. You guys have worked with that before. But what we have to get is the base graph. And if I were to just look at this and go, well, I can graph this and just get the table of values, what I end up with is, well, I'll show you. I've put in my graph so that I've got log x over log 3. You could page over there and see that it's log 3. And I've graphed it, and that's what I expect to see on a logarithmic graph. I'll see that I've got x-intercept of 1 here and so on. This would be an asymptote at y equals 0, blah, blah, blah. But the problem is when I go to find my table, so I'll go second function table, I don't have control over my x values very well. So I've got a bunch of error. Okay, well, I can see that after 0, I've got a bunch of error, but I know that there's data in there and lots of it because it goes very steeply, looking back at the graph, it goes very steeply in an asymptote here between 0 and 1. So all of this information is hard to find. Now, if I were to use the inverse of this graph and go to, I'll just get rid of this now, and use 3 to the power of x like we were using before, then I use my graph. Now, all of those really difficult to find numbers are actually on the x-axis. So that's easier to control and easier to see. If I use my second function table now, I've got all kinds of great solid values for my y-axis, or my x-axis, sorry, and I can see lots more stuff happening on the y-axis that I can control. Now this one also has some funky decimals, so it might actually be easier for me to use math, dun dun dun, than use my calculator. So let's see how that goes. Now if I'm going to do a table of values for this, I'm going to use the y equals 3 to the power of x and just swap the values. So what if I just said x equals 3 to the power of y? Now, I'm going to have to do some weird stuff here, but I could do -2, -1, 0, 1, and 2 here, and then just plug in, because I'm not using my calculator. I don't care whether I use y or x as long as I'm doing the math. So I can go 3 to the power of -2 is 1 over 9. 3 to the power of -1 is 1 over 3. 3 to the power of 0 is 1. 3 to the power of 1 is 3. And 3 to the power of 2 is 9. Now, if you want to make these into decimals, you'll see that they do line up with the table of values that we created in our calculator, but it's a little easier to read them if they're fractions. That's kind of up to you. If you're happy with decimals, that's fine. Just make sure that you're using non-repeating decimals and not rounding off, because you'll get funky results. Okay, so there's a little bit of leeway in how you set up your table of values. I prefer the nice tidy way of actually just using math to do it. So now I've got my x's and my y's, so that 3 to the power of -2 equals 1 over 9. So that's what I need to do there. This is going to be my base graph. And as you could see in the equation down below, I've got 1 and 0. So I've got my I've got my intercept there, and 3 and 1 would be here, and then 9 and 2 would be over here. So I've got my asymptote coming up here, comes through here, goes that way. Right, so that's my base graph before I move it and do all my transformations. Now, that's what I'm supposed to be doing with this base graph. And I need to be able to look at that formula and match it to this one and pull out all the extra values and then make my new points the way we did before. So, let's use some color coding. Looks like, let's start with, just go from this side to this side. What's k? Well, y minus k, looking for something outside the brackets here that I would put over here or whatever. There isn't anything, k is 0. So there's no k. We don't have to worry about it. How about c? C would be something that's being multiplied out here. There is nothing, so we'll just call it 1. That's easy. Boy, we better find something here soon. Now log base 3, the a is just the base, no one worries about it. The next thing we come in contact with is d. And d is outside the brackets. There's nothing outside the brackets, but wait. That's where we would stop and look at how this is set up and realize that this needs to be adjusted, because this isn't x minus h, this is 2x and a number. So we're going to have to take that 2 outside the brackets, and that leaves us with x plus 3 inside the brackets. Now let's look for d. There it is. So d is 2. You have to be careful about that one. Always make sure that your x is alone. If it has a number affixed to it, a coefficient, then you're going to have to factor it out, and that's going to be the d. So the next thing we worry about is h, and it has to be x minus h. So if it's plus 3, not 6, but 3, then that's going to be a negative 3. Right, so to find our new set of data points, we can make a new line on here, and we're going to have to, I'm just going to move this, we're going to have to go x over d plus h, sorry about the marker, but I'm going to be mucking with it here in a minute anyway, c times y plus k. So, close bracket. With the values that we have here, I think I'm just going to go over it all in blue and put in the numbers. But, so we've got x over, our d is 2, plus h, so that would be, whoops, let's color code this, it's fun, over 2, plus h, which is negative 3. C is 1, so it doesn't really matter. So we could just put in a y there, because 1 times y is just y. And then the plus k is 0. Oh, well, that means we're not actually changing our y values. That's nice. So we just have y. Fabulous. So all we really have to do is change x. So, 1 over 9 divided by 2. The 2 and the 9 are on the bottom, so it becomes 1 over 18. Minus 3, you could use your calculator for this if you want. It's going to be kind of a funky number anyway, so it's not really going to change how our graph looks. So we're going to go 1 over 9 divided by 2 is 1 divided by 18, which gives us 0.005. Minus 3 gives us approximately negative 3. So I'm just going to round that off to pretty close to negative 3 and negative 2 because the y didn't change. Now, negative 1, or 1/3 divided by 2 is 1/6 minus 3, so 1 divided by 6 equals minus 3, gives us negative 3.5. So negative 3.5 and negative 2. We're just sketching these, it's not a really big deal. Those ones are going to be on that downward slope anyway, so whatever. 1 and 0, so I've got 1/2 minus 3. Now we're getting into a little bit more tangible numbers, so I have negative 2.5 and 0. 3 divided by 2 is 1.5 minus 3 gives me negative 1.5. Now we've got a bit more of a change going on. Now 9 divided by 2 is 4.5 minus 3 is 1.5 and 2. So now we can plot those points to see where our graph is supposed to be. I've got negative 3 and 2 here, so I'm going to go negative 3 and negative 2. So put that there. Negative 3.5 goes over here a little bit more. Actually, let's change that a bit. Negative 3.5 and negative 2. Whoops, my bad. Negative 1. So I go to, where was I? Negative 3.5 and negative 1. There. What have I done? Negative 2.5 and 0, so that's going to hit that line there. So I've got a point here that's not working. I'm just going to keep going for now, and then I'll see where the point should be, and we'll fix it. And that's a good way to just visually decide whether or not a point actually fits your data. And I'll worry about that in a second. I probably just did some math wrong. Okay, so, okay, I can't stand it. I got to look back at this point. This point doesn't work. So 1 over 3 becomes 1 over 6 minus 3. 1 divided by 6 equals minus 3 gives me, see, I must have made some sort of typo in my book because this is supposed to be negative 2.8, which makes a lot more sense. So I fix it. Negative 2.8, approximately there. Now it's in line. Yay! Sorry about that, kids. Now, continuing on, negative 1.5 and 1, 1.5 and 1, 1.5 and 2, so now we're over here. And you could continue with that, or you could just follow the fact that this graph is supposed to look like that, and just kind of keep it going.